All right, we're going to wrap up chapter 10.3 today. And in today's video, we're going to look at, or videos rather, we're going to look at how do we determine the appropriate test for a given series. We've got a lot of different approaches that we've discussed thus far. And given just a series out of context where you can't just look at the chapter that it's in, it sometimes can be difficult to tell what tests to apply. And so I'm going to just quickly recap what are the tests that we've seen thus far. I'll mention some of the clues that you should look for when trying to identify the appropriate test, and then we'll do a couple of different examples to try to put that framework into practice. All right, so to start, let's recap our main tests. We've looked at, I would say, 5 or 6 main classes of tests. All right, so tests for convergence, or divergence. Okay, the very first one was the nth term test. And the idea was if an does not go to 0, then the sum of an diverges. We also talked about geometric series. All right, and so we said that if r is less than 1, then the sum of c to r to the n from n equals 0 to infinity was equal to c over 1 minus r. And if r is greater than or equal to 1, then the sum diverges. Okay, we also looked at telescoping series. And it said the way that we evaluate these is we computed the partial sums, and then we would take a limit and that would give us the sum of all of the terms. Okay, so if we can find a formula for the partial sums, we can take a limit of that to compute the total sum. All right, now these two tests are very narrow. They only apply to a small class of different functions that have some very, very specific properties. The nth term test is more general, but it can only tell us whether a series diverges. It can never tell us that it converges. Again, it only tells us about divergence. And that brings us to our last couple of tests. We've got the integral test. And that the idea was if we looked at the integral from 1 to infinity of f of x dx, we could compare to the area represented by the sum, and we found that they do the same thing. Now, there are some stipulations there that we need to be aware of, but I'll refer you back to the integral test videos for all of those specifics. Okay, so that one's a little more general. It applies as long as we can actually, well, evaluate that integral, and we have terms that are positive, decreasing, and continuous. And then 5 and 6 would be the direct and the limit comparison tests. And the idea there was bigger than big means big, and think divergent for that, and smaller than small means convergent. Okay, so those are the 6 tests that we've seen thus far. We're going to add a couple more to the mix when we talk about alternating series in the next unit. But for now, how should we think about actually applying these tests? How do you know which ones to use? All right, well, sometimes it's not going to be obvious just by looking at a given problem what's the right one to do. And so my general approach is to look at the nth term test first for just about every problem, And sometimes I'll do that in my head. Sometimes I'll actually write it out. So you may have noticed that when I work out an example, I don't always reference it, but I often do. So I would say try this first. Then after that, what you're going to want to do is look to see if your series falls into one of those narrow categories of geometric or telescoping series. And then if that fails, then we may opt for comparisons. And in this case, it's going to depend on whether we actually think we can evaluate the integral or not, as to whether we choose the integral test, the direct comparison test, or the limit comparison test. Okay? So basically, I kind of try to work down the line in order here, starting with the nth term test, then going to geometric or telescoping, then the integral test, and then as a last resort, go with the comparisons. Okay? So those are the rules. In the next video, we'll start applying these to some examples.